Okay, so my name is Elise Day, and I am from Boston, Massachusetts, and we have Dirk de Ridder from Belgium, and we have Rami Onur from Turkey. And today we're going to talk about in the wake of mesh concerns, the options for biological grafts. So I have nothing to disclose. My institution funded the trip. Dr. de Ridder is self-funded for the trip, but he does have affiliations with Astellas, Medtronic, and Coloplast. And Dr. Onur has no affiliations to disclose, but his trip was sponsored by Allergan. And so again, regarding the in-app evaluation of our workshop, you can get to the evaluation for the workshop as well as participating in the questions during the workshop by selecting program by day, and then the workshop for current role of biological grafts in the era of mesh controversy. And then the evaluation will be here, and also in this area will be the questions. That way you won't forget before you evaluate. Also, a shortened version of the handout has been provided on entrance to the hall. Full handout for all workshops will be available via the ICS website. We'll remind you to silence the mobile phones, and please refrain from taking video and pictures because PDFs of all the presentations will be available in full. So my part of the talk is regarding mesh complications, the FDA warnings in the United States, and cause for concern regarding mesh, and a bit about the biochemical evidence in tissue repair. So here's the first question, if everyone's ready to vote. The question is, in the past 10 years for anterior wall prolapse, what % of the time have you incorporated a synthetic mesh in the repair? And I'm going to vote as well. This includes before warning. I think there is something wrong with this microphone. Should we change something? Sorry about the technical difficulties. It seems like it's turning on and off. Thank you. Okay, this will hopefully be better. And okay. Next slide, please. So in 2008 and 2011 in the United States, the FDA issued public communications about vaginal mesh through its website. And since these reports, the use of vaginal mesh has been decreased not only in the US but worldwide. IUGA recently published a document regarding the fact that worldwide decreasing usage of mesh is seen in most practices. And we all know the evidence about the old mesh products. Marlex, Merceline, Proline, and Gore-Tex were considered to be not open pore. But currently available mesh, through publications, numerous publications, and also internal industry emails. Recently I did a review for a legal case and had access to internal emails from Ethicon. And all of the problems with mesh have been known really since very early on, with shrinkage, degradation, altered geometry, folding, bacterial colonization, inflammation, and rigidity. So this is the work of Pamela Mawali, and you can see here pictures of Gynemesh, Ultra Pro, and Restorel. And on uniaxial loading, that impacts the pore size, and so the reality of the pore size is different in vivo than it is on the shelf. Other new findings regarding mesh is there is degradation over time. This is, again, Pamela Mawali, information on pro-inflammatory macrophages. The black is the mesh, and through CD68 staining, you can see pro-inflammatory macrophages around AMS perigee, which is an older mesh, Gynemesh TVT Secure, and no macrophages in the control vaginal tissue. So, as we're all mistrusting mesh, and also the legal climate, at least in the United States, decreases our usage of mesh, what do we have to work with if we're planning on using a graft? The FDA did require post-market surveillance studies for remaining products after issuing its warnings, and these post-market surveillance studies are called 522 studies. These are intended to evaluate the success and complications of devices on the market. And this issuance included manufacturers of xenografts, animal-derived, but did not require manufacturers of allografts, the human cadaveric tissue, to run these studies. So some of the animal-derived products came off the market at that point. For example, Pelvisoft, which was a porcine product, had significant encapsulation in the literature. Some of the studies were done by Ajay Singla, and it was often extruded, and so that product chose to come off the market at this juncture. Recently, there was a European consensus statement in 2017 by the European Urology Association as well as the European Urogynecologic Association, and they reported on implantable materials, talking about the overall surface area of the material used, the mesh design, stating that the pore size less than 75 microns puts the product at risk in the patient. The actual material is a consideration, but they didn't actually discuss biological grafts in any detail. We're left with questions about what these biological grafts as we all look to using them. So the allografts are the cadaveric fascia and the dura mater. These are human products. The xenografts are porcine and bovine. The autografts would be fascia lata or rectus fascia harvested from the patient herself. And then, of course, there are the synthetic materials we've been talking about. Grafts differ in their origin, the biological grafts, the autograft, allograft, xenograft. The source, that being from the dermis, the fascia, pericardium, or small intestinal submucosa. The life stage, whether it's fetal or adult. And the proprietary processing, the washes, enzymes, chemicals, lyophilization, cross-linking, for example, using glutaraldehyde, and sterilization, how is it sterilized, ethylene oxide, gamma irradiation, etc. Currently available in the United States are Repliform, which is human dermis, Axis, which is human dermis, Suspend, which is human fascia lata, Zenform, which is fetile bovine dermis, and Matristem, which is porcine bladder matrix. So the processing of Xenoform is non-cross-linked fetal porcine dermis. The matrix undergoes chemical viral inactivation as well as sterilization with ethylene oxide gas. And Matristem, which is made by A-cell, goes through a 6-layer acellular and non-cross-linked matrix derived from porcine urinary bladder. The allograft processing, Repliform, is an acellular, cadaveric, non-cross-linked dermal matrix, which is sterilized to ensure clinical safety. And then the two products by Coloplast are Axis and Suspend, and these are both non-cross-linked and sterilized using a proprietary process, Tutaplast, to prevent the transmission of pathogens. You don't need to remember everything on this slide because we'll be going through this later in the talk, but it's just to give you an overview. So there are concerns about allografts, the human tissues, including transmission of bacterial or viral disease, transmission of prions, durability, degradation of the allograft, inconsistent quality from some tissue banks, cost, depletion of tissue banks, and an unpredictable host response. The ideal material would be biocompatible, acellular, with abundant collagen and elastin, a preserved extracellular matrix, high tensile strength, It should be durable, free of infection and erosion, and inexpensive. So next we'll go to Dr. DeRitter, and he will discuss what research says about these biological materials.